Right up here is an OS&Y valve. It's an 8-inch OS&Y. That's the main feed for this building right here, coming in off the street. And it heads right over here to your backflow preventer. You got a couple of 8-inch OS&Ys on either side of them. And that's your feed side for the fire pump. Goes through the wall into the fire pump room. Eventually there's going to be two feeds feeding into the fire pump room. One coming from the street way over on the other side over there. We haven't got that far yet, but that's what it's going to have two feeds feeding this fire pump. One from the street over there and one from this side here. And you also have another pipe here that's going out. That's going to feed over towards Enders and some of the hospital over this way as well. So I suppose we can head into the fire pump room and we'll go over the valves in there. Continuing from the valves over there, the pipe comes around here. It's going to go down through your main fire pump right here. This is your suction side right here. It's also, you have a fire pump bypass up there with a couple of valves up there in between the check valve. Okay, and that's your discharge side of the fire pump. Comes over to your first valve over here. All the valves have tags on them, and they're telling you what they are and what you got to do when you get upstairs. Pretty much all the floors are cross-connected, so you get two risers, two sets of valves. So whenever you have to shut off a floor, obviously you got to kill both valves. But this comes up here. Okay, this comes down here, goes up. This is your test header, which runs all the way down through past the elevator lobby, through the fuel tank storage area, and up to the top of the hill over here. And let's see. This pipe comes over here. You also have your vertical turbine over there. If for some reason this pump fails, I believe that'll activate. It's got a holding tank under the floor here. It'll suck water out and help out with you know, putting out the fires and stuff. So the pipe's going this way, right here. This is, you got a T right here. This is what I was saying in the other room. This pipe right here goes through and that heads towards the other buildings for fire protection over there. It's my understanding they're going to get rid of an older fire pump over there, and this is going to help take care of that over there. So it comes across here through this check valve, down under this alarm valve here. This is feeding like combination standpipes, the high systems and the low systems. There's going to be two systems in this building. There's a low system, which is going to take care of sub-basement all the way up to the 4th floor mechanical. And then you have the high system. It's going to start on the 6th floor and take you all the way up to the mechanical floor, pretty much on the roof, up to the 11th floor. We have two sets of pressure reducing valves. Okay, these bigger ones right here, these are for your low system. Going to come through and keep the pressure where it's supposed to be. And these smaller ones here are for the high system. All the pipe goes out into the main hallway, tees off, goes to both stairwells, runs up, and that's what it's doing there. But these are all just you know, isolation valves for your pressure reducing valves. Same over here, just isolation valves. Is there any questions so far? Okay. Well, I guess we can move on. Oh, while we're here, this is your kick-ass air compressor. This baby could probably power up the whole block, but right, what we're using it for, this gang compressor is it's taking care of three things right now. It's piped into this 1.25" copper. It's feeding a dry system, which is doing about 21 sprinkler heads in the ambulance bay. And it's also goes up and it feeds two other small systems. It feeds the MRIs, feeds the air on MRI on the second floor and the MRI on the 7th floor. Right now, that's all it's doing. Okay, that's an old school dry valve. I think everybody probably knows how to use them. Any questions on the dry valve? It's not like a DDX or any of the new stuff. You have to actually take the faceplate off to reset that thing when it trips. And it has an accelerator on the top of it. So I think the air compressor here is set between 60 and 80 pounds is what this will come on at. And we have air maintenance devices hooked up to all the three different systems requiring air. On this one here, we're pushing through about 45 pounds to hold back the water pressure on the dry system. And upstairs, it's a lot less because they're just pre-action valves. But that's about what we got right here. Now we can take a walk over into the stairwell over here. And on the base of the risers, you have control valves. There's going to be two control valves on this side. One's for the high zone, one's for the low zone. And same with the stairwell over here. You're going to have one for the high zone and one for the low zone. There's one other sprinkler system down here that it's its own zone off of the mains. It's for the tank room sprinklers, and that's directly in front of the elevator. And it's in the elevator lobby. You pop a tile, it's right above the ceiling there. Let's take a walk outside here and I'll show you where the valves are on this one. They're informative. They tell you that, for instance, what it's doing and what you have to do to kill the riser, and especially for these floors. So this valve is one of the two valves that you have to shut off to service the sub-basement sprinklers right down here. There's another valve in the stairwell over there. And right on the tag, it's going to tell you that you have to, this is one of two valves you have to shut off. So it's, they took the guesswork out of it, unlike the old days, you know. So I like that. And right up there, it also, I got them on the right places. One's high zone, one's low zone. The higher one is the high zone, and the lower one is the low zone. But it says it right on the tags. So we can walk down the hallway and go over to the other set of stairs, and I'll show you. The other side is actually on an intermediate landing, but there's a tag right on the tile. But if you lift the tile, you're going to see that there's a 4-inch control valve coming right across here. And all this 4-inch control valve does, it feeds over this way, and it feeds a sprinkler system right through the door here, right up in the fuel tank storage room. That's all it's doing is the sprinkler system in there.
Is there signage in there where the valve is located?
The valves are right here.
No, is there signage in there where the valve's located?
Which valve is that?
Wherever the sprinklers at? The fuel.
Yes, there's big, you know how we had in the pump room, the big labels? That's in there as well. Okay. Remember how I said that there's two valves to every floor? This is the other valve for the sub-basement. So there was just no room to put it downstairs. So they put it up here, piped it down, and this is the valve number 2 for the sub-basement sprinkler system. And then these two valves right here are for your main shutoffs for the risers. One's a high system and one's the low system. And they're listed right there on the tags.
So if you got an issue upstairs on the high side, you close this valve and the one over there, and it's going to stop everything from 8 up. Is that what you said was? A 6 up?
Yeah. Say you wanted to isolate the high riser.
Right.
That'd be this one right here. And you actually put an H on it, but it's on the tags here. If you wanted to just work off of this riser here, from 6 through 12, you could just shut this off here. But there's also floor control valves on every floor.
So you got to close it off up there.
Yeah, and they're check valved in too. So if you your check valves are holding, you could drain the riser without having to close every single valve as well. That's why we put them in. Okay. Well, we can walk up to the second floor. I'll show you one of the pre-action systems and where the cabinet is. And second floor. This valve is doing the, what do they call it? Basement floor, which is actually the first floor, but they're calling this the basement. And then, once again, there's 2 valves you have to shut to work on that system, and it's like that all the way up. There's 2 valves for everything. The ambulance bay is the dry system downstairs inside the pump room. That's just doing the 21 heads out there. This is a pre-action system. I mentioned there's 2 pre-actions in the building, in this new part of the building. Both of these pre-action systems are doing the MRIs. And there's copper feeding into the MRIs. And you see a basic DDX double interlock pre-action valve right here. Takes 2 things to set it off. As we all know, it takes a smoke detector or heat detector, probably is what they're using. So that's got to go off to activate the solenoid to trip the valve. But you might get, if the valve trips, you're only going to get water to a closed system, so you need 2 things to set off a pre-action system. You need it to electronically set off by that, and you also need a head to release so it'll fill with water and get out. That's why we like these, because it's they're foolproof. I mean, people put them in their houses all the time because you get kids bouncing balls. If they can afford a sprinkler system, you break a head, you're still not going to get a, water damage. So that's all that is. It's like extra protection for if something was to happen. When I show you the MRI and what this is heading to, right through these doors over here, guys. The pipe runs through over here, runs into the MRI little mechanical room here. And it feeds through there. These heads here, don't let these sprinkler heads fool you. These are coming off of the MRI piping. Just this room here. Everything out there is off of your regular wet system. The mechanical rooms are fed off the pre-action system, as well as inside there. And we can poke our heads in there and take a look too. So this is the biggest part of your pre-action system right here. And everything up above the ceiling is non-ferrous. It's all done in copper, brazed, and special heads and all that. Special head plates, because we don't want any, as we know. Right. I don't want to come in here because I'll get so much shrapnel in my eyes from over the years. I'll probably pull the...
magnets?
Yeah, the magnet.
Don't come in after Tuesday.
Exactly. Yeah, once again, everything's... all the floors are dual fed.
Yeah.
So when we first came up the stairs over there, I showed you that's one of the 2 valves you got to shut off. And those tags tell you that too. When you look on them, it says you got to shut off 2 valves to work that, work on the system. And they're combination standpipes, so you got your fire department valves on them and your sprinklers coming off of them. The pipe to the right is obviously the express heading up to the high system. So that's the high system, because this one's got the sprinklers coming off of it. We can probably take a... I don't have to show you guys every single floor, because they're all typical all the way up to the 4th floor. But what I would like to do is possibly take you up to the 7th floor where the other pre-action system is. And that way you can see where the valve is and take a look at that. And then I'll show you where the fire department valves are and stuff like that.
On that pre-action, is there any
It doesn't have
drains, anything like that anywhere that we should know about?
I don't think so. I think we got it pitching back pretty good. There's a low point drain on the valve. When it trips, there's a low point drain right there on the main valve. I don't think you're going to get that much water.
drain it from?
Yeah, unless they had to go up and down under beams and stuff, but I don't think they did. I chased this one out pretty good.
Yeah.
And, well, you know, it does drop down, doesn't it? I'll take a look at that and find out. So I didn't install all this pipe here. I kind of got here to this project and try to help finish it. So, for the upper zones, starting on the 6th floor, we lose a stairwell, so now we have the valves shoehorned in here. Okay, so this is one of the 2 valves on these floors that we have to shut to service this floor here. And the drain valves, you get a little access panel right up top.
This is all the patient floors.
Yeah, I think so, yeah. Is that what it is?
6 7
What is it, just one stairway?
6 is like
6 is like this as well. I just chose to stop at this floor so I could show you the pre-action. This is your pre-action valve for the 7th floor MRI. It's the same type of valve, everything is downstairs on 2. Okay, and it's piped into the MRI right over here. Take a look at that, I guess. Okay, I believe the MRI is piped through the MRI mechanical room. Okay. A couple of heads in the mechanical room, just like downstairs. It's piped off of the pre-action system for the MRI mechanical little space here. And it penetrates into the MRI over here and picks up its heads for the MRI from that. Eventually, guys, there's going to be another tie-in from the pre-action system, and it's going to come all the way down here to this meg room. And it's got one head coming off of the copper pipe down there. It's going to come down here and feed this meg room right here. I come in off the top, and it's going to have one head inside of this. And okay, guys, right up these stairs on the top of this landing here is one of the 2 valves needed to shut this floor off. Okay, this is off of the high zone riser. This one over here. There's another one in the stairs over there. You have to walk up to an intermediate landing, and it's the same exact thing that you guys have seen below us on every floor. So no surprises. There's an auxiliary drain right here off of this lower system that's piped into the drain right there. And I believe there's another one around the corner, but what it is. Any questions on this, guys? Maybe we'll get downstairs and see. Yeah, I can show you where that valve is on the ambulance thing. We'll take a ride down to 2. We'll get off at 2. We'll walk down the hill to where the ambulance bay is. This valve right here is to test the dry system. So this is where we'll be testing it from. Okay. I just wanted to let you guys know because...
This valve? Small one?
Yeah, pointing right at you.
But that one is for the ambulance space, is it?
For the ambulance space, right over here.
Okay.
Yep. Okay. But that's your test valve right there. That's where your test valve is, guys, for the dry system, exactly.
This is a 1350, which is a wide delta starter, and that one over there was a 1930, which is an electronic soft start and soft stop controller. So each of these controllers are equipped with an automatic transfer switch made by ASCO. In fact, ASCO owns Fire Control now. They've owned it for about 10 or so years, and we use the best, nice new ASCO control module that gives us all kinds of information from the generator as well now, which is kind of nice. So, I know you guys pretty much know how fire pumps work. You have a jockey pump controller that is a pressure maintenance pump. Then you have a high zone controller and a low zone. Which one's which one? I can't remember which one's which.
This is well. This is for the turbine.
Okay.
And this one here is doing everything.
Okay. All right. So I think they're both looking at the same system pressure, right? Same,
Yes, I
they're both,
believe, yep.
Tapped into the same sprinkler head. So here's your sensing line for this one. The sensing line is over there for the other one.
Correct.
Each of these controllers have a transducer. It's located right at the bottom here. So this takes the place of the old Berkwood pressure switches. And that pressure switch sends a signal to the Mark II XG. And I'll look at that in a second. But, so as far as the information on the screen, it tells you all the time, at any given time, it tells you what the system pressure is, time and the date, and what the voltage levels are. And when the pump runs, it gives you the three-phase current as well, right in front of the door seat. Because by code, we have to build controllers now, but you don't have to open the door in order to test them and take readings. So you've got your little idiot lights here that tells you what's going on, tells you normal power is available, or if the transfer switch is in the normal position, or if it's in the transfer switch in the emergency position. You can access your start and stop set points right through here, very easily negotiated through the menus. Right now we still have, you notice it has a big sticker here that tells us that the interlock jumper is still in place. And that's just a little jumper that's on this main circuit board, so that if somebody were to come in here, flip a switch on without taking into consideration what the system pressure is, this will not start on a pressure drop at the moment. That's all it means. So once this thing is in for its final operation, that jumper will come out and stay in the bottom of the cabinet. It's just a safety. So, go ahead.
This pump is basically for a backup for this system?
I believe
A
that's,
booster?
yeah.
If this thing loses pressure, this thing's gotta be set at a higher pressure, I assume?
I'm not 100% sure.
I believe it's also a case for some reason from 9/11 if the city water pressure loses power. 40,000 gallons below here, which gets
got a
certain number of
self-contained.
hits for a certain number
Nice.
period of time. Not a massive fire.
Yeah, there's some new codes out that say you have to have a secondary water supply.
Yeah.
So in your case, it's a big swimming pool down below.
How big's the tank down
40,000 gallons.
there? Yeah?
Is it
It's 40,000 gallons. Just for size, see the concrete columns? The four of them are the perimeter of the tank. And it's about 8-foot ceiling down below. The access is right around the corner in the floor.
These controllers have the ability to store 3,000 events. An event is anything that happens, like a start push button or a pressure call, loss of power, it'll record that. It records every hour. I don't know if you guys have had use for these, have had to look through any histories yet. I'm sure you get these elsewhere on the campus, don't you? The Mark II controllers? Quite sure. No?
I don't think so.
Well, we need to start changing them out then.
Well, we actually added
Yeah, meters.
meters, but they're
Oh,
just for
really?
voltage and amperage stuff.
Someday I'd like to see how you did that, because everybody's always asking us to do that.
Yeah, they cut a hole in the front door and put like a, I think it's an Eaton cut and hammer meter they put in.
Okay, I'd love to see that, yeah. But the nice thing about these controllers now is they store everything on a flash drive. So that just goes right here. Yep. It sits there and glows, and every night, at midnight, it sends a file to that little flash drive of all the day's history. And most of the history, fortunately for everybody, is that it just takes a picture of the pressure every hour. So you'll be able to look back on an Excel spreadsheet on your computer. And as a matter of fact, there's an incident this morning that I had to go look at one of the colleges where they had a failure back in early August. So they asked me to come in to retrieve all the data off the drive. They had a fitting let loose somewhere in the building. It had nothing to do with the pump and the equipment, but they wanted to know what the history of the system was. So I was able to go back, pull all the information out of this, put it up on a flash drive, and actually hand it over to a lawyer on a flash drive. Yeah, it was not very much fun, but fortunately I'm not in the middle of it. But it's handy for if you like, let's say you have issues with a jockey pump, or you may have a check valve that's not working quite right. This will tell you, what the history of the pressure is. So it's kind of fun to look at every now and then.
So how do you access that? Do you need software or
No, you don't. No.
you just pull that flash drive out?
Yeah, what you want to do is, let's say you had something happen during the day, and you wanted to record it right up to the last minute, right up to the minute. There's a menu in here that says write to USB. So you do that function,
Right.
and it'll actually write up till now, what it is. Otherwise,
Instead of midnight.
Pardon me?
Instead of midnight, instead of,
Yeah, in other words, if I just take the flash drive out, it'd be good up until midnight last night on the flash drive. Okay? But if you do the safety disk, like right now,
stops that time?
yeah, it'll record right up to now, you know?
Yeah.
That's
So,
what it's all.
yeah, now tonight, it'll take another, right, again, at midnight tonight, the latest 3,000 events, so that's how it works.
And when you open the file, it's in Excel.
Yeah, you can open it two ways, like with my laptop, if you just click on the file, it opens up like a, the old notepad or
Yeah.
notebook type thing. And it's a little bit hard to read, but what I do is I open up Excel first and pull it up. You have to go to all files, not just Excel files, and then you hit finish, and it converts it all. And then all you do is go through, it's just 2 columns, and you open 2 columns up a little bit wider, it shows you all this stuff. It's pretty cool. And this morning, what I actually did was, I actually created a PDF out of that, so you couldn't change it, you know?
Right.
Yeah. So, what was the point of the whole story? Oh yeah, it'll tell you on the flash drive, it'll give you month by month. It'll say September, October, November, so it actually segments it to the month. It's pretty cool. There's a test port here. If you wanted to test it. And I don't recommend you use this method, but it's here because code says we have to build it, okay? There's a test button there. What that test button does is it opens up the solenoid valve right here. And it simply just pisses water to the floor out of the sensing line, okay? So it simulates somebody opening up the ring.
Right.
And it starts with a pressure drop. So what I don't like about that is all solenoid valves get clogged from time to time, especially with old sprinkler water. So a lot of times I'll get a call back and say, the thing is dripping. So it's just a pain in the neck. It's a maintenance issue. So, but it has to be there for code, okay? And this one, you don't necessarily have to pipe it anywhere, like this is just going to the floor, which is perfectly fine. But you'll see, if you hit that test button, you'll have that sprinkler pressure pumping right on the floor. So that's another reason I like to see it.
So that doesn't transfer power, just.
Oh, God, no, just that's a controller on a pressure drop. That's all, purely a pressure drop. What we always recommend for a weekly test is to open up a 2-inch strain that's system-wide, if your system can handle it. And in fact, a couple of the guys and I were talking earlier about how to do that. You don't always have to shut off the discharge valve, but some buildings you like to have it off so you don't bump the dry systems.
Yeah.
So it's all a judgment call with you guys as to how you typically would test a system. So I like to say pressure drop to simulate the jockey pump. The sprinkler head opening. So, and that way you can see where the jockey pump starts, write your settings down, and let it go a little further until the main pump comes on. What's nice about the digital displays is that you can obviously just use one of them for your real pressure instead of looking at a mechanical gauge somewhere in the system. So far, so good? Any obvious questions or?
That's something, you brought up a good point, that's what they're gonna wanna see.
What's that?
Proper testing sequence for all the pumps and the controls.
Mm-hmm. Yeah. Well, every building's a little bit different depending upon the hydraulics of the building.
No,
So
exactly.
Brian can't even tell you, because he hasn't been on campus, doesn't know all the buildings, but we can tell you what's very typical. We had a discussion about the pressure relief, the casing relief valve in the pump. We had a question as to whether or not you should rat raise, Typically, a churn test is just simply that, a churn test, where you don't bother rat racing, you just start your pump up and let it run deadhead. It's called a deadhead test or a churn test. And the only issue you've got is overheating the pump, because some pumps, depending upon the size, if you let it run for 10 minutes, they might get very, very hot. Some of them won't even, they'll be cool as a cucumber. but
Well,
some
we
get real
understand
hot.
that. We're familiar with all the other buildings, except for this one.
Well, it's no different than your other building, except you gotta check it, make sure your casing relief valve works all the time, and just be smart about that part. That's what the casing relief valve is for, to introduce enough cold water into the pump, so it doesn't, get too hot on you. So. Annually, you want to do you have obviously you do a full flow test every year, transfer over the generator.
Yep.
The best way I check a transfer function is to start with the main power from outside the controller.
Yep.
You can shut it off here now, or you can use these selector switches, but I prefer to have somebody put the main switch to simulate
That's
a
what we
real
do.
power outage. Perfect.
We open up the main feeder breaker and let it just fire up.
Yeah. Code says you have to have emergency power available up here within 10 seconds.
Right.
It doesn't have to be switched over, it doesn't have to be running, but you have to have power available.
At 10
Okay?
seconds.
Yeah. A lot of people will think, you're not flowing water yet. Well,
Yeah.
you don't really need to. You have to be ready to. And when you do, let's say you have to shut power on and off, You know the old issue with these controllers, with most all controllers, you need to shut off the generator power first, and then shut this one off so you don't call the generator to run by mistake.
Right.
Okay? Now with these controllers, I always recommend you fill this one back on first, like you always do, but count to 10, let the electronics come up, let the lights light, okay, before you put the other one on. That way you don't get a, this thing's not saying, oops, we don't have power. Just let it settle in for 10 seconds first. That's the only thing I recommend. Sometimes there's questions on the retransfer function. Let's say you weren't testing and you actually had a real power outage. So you lost power. This unit would start the generator. It would switch over because presumably you've got the call leads, and I bet you that's what these are right here, the 2-hour fire rated cable. Okay? So this calls the generator to run, it switches over. The pump doesn't start, it's just sitting there with standby power. Okay? No need to call the pump on unless there's a pressure drop. If power is restored, then the controller waits 30 minutes before it switches back. That's an NFPA 20 code. Okay? A lot of the transfer switch people will go through and do a coordination check for a new building like this one and say, oh, you got to change that back to 10 minutes, like all the others. Don't want to tell you that. By code, that has to be 30 minutes. Now, you can short circuit that. You can change it. If, let's say you don't want to wait the 30 minutes. Yeah. You guys can do that. You can change it. You can transfer it back as soon as you want with this switch right here. Switch right back to normal. Okay. Yep. But if it was left on its own, it'd be 30 minutes. You guys know how the emergency run handle works? It's just a kill. It just pushes in the contactors. Yeah. There's actually, believe it or not, there's actually an electrical button in the back that will try to start it normal first. Okay. See that one back there? Push it before these even push in. Try to start it normal. You give it a second attempt, if you will. Because the last thing you want to do is really start it across the line. So, but it's an emergency. That's exactly what it's for. I've seen times when I've gone into not well-kept pump rooms in facilities that don't know what they're looking at inside their buildings, and the guy says, the pump stops every now and then all by itself. I'll walk into the room, and there's a folding table leaned up against the controller right here. And every time they slam one of the doors, it vibrates slightly and pushes that start button in, okay? No, seriously. So, just gotta be careful. What else? Anything else?
Is there a recommended maintenance on these control panels? Is it
Well,
annual maintenance? Is it?
Yeah, NFPA 25 says you're supposed to have the controller gone through by a factory authorized person to make sure it's working properly. Correct. So we do offer that for several campuses around here, as a matter of fact. We do it with Beth Israel. We just got done doing it with Israel a few weeks ago. And what we do is we come in and we put it through all the normal start modes of operation. We do a generator test. We don't do any flowing naturally. Right. We just go through like doing your weekly test, but we take it to a whole different, degree. Okay? And we give you a laminated check sheet. It really goes a lot further than what they really recommend in the guidelines. But we do offer it. So.